Alright, today we're going to start our unit on exponentials. Today we are talking about the properties of exponents. So let's start off by reviewing what exponents are. So if I have 2 to the power of 3, that just means to multiply 2 times itself 3 times. So 2 times 2 times 2, and we know that 2 times 2 is 4, and 4 times 2 is 8. Okay? Similarly, for x to the third, or x cubed, it's just x times x times x. X to the third is just a more simple way of writing. Alright, for this last one, this is very similar. It's just 5 times x cubed, so we just think of it as 5 times x times x times x. Alright, now let's get to some algebra. Okay? The question here is, can we add x squared and x cubed? Hopefully you guys remember from older units that we can't because they are not like terms. In this unit, we're going to talk about multiplying them, though. Okay, so we have x squared times x cubed, and we know that x squared is just x times x times, it's just x times x. And x cubed is x times x times x. So we see if we combine these all, we actually have x 5 times, which means this simplifies to x to the 5th. Now hopefully you noticed something interesting happening here. We had 2 x's, and then we had 3 x's. So when we combine them, we have 5. So we can actually just add the exponents when the bases are the same. This is what the base is. So w to the third times w to the fourth is w to the 7th. So we just add 4 plus 3. Now here it gets a little bit more tricky. We can write this one out again, and we can combine them, or we can use our trick. So we have 1x here, 4x's here, and that's it. So we have x to the 5th. We have 3y's here, and 10y's here, so we have y to the 10th. We have 2w's here, and 6 here, which gives us w to the 8th. And we've got that 5 hanging out front, so we'll just pop it right on at the end. Alright, so go ahead and pause the video and add this rule to your notes. So, a to the n times a to the m is just a to the n plus m. If they have the same base, you just add their exponents. Alright, next step, we're going to go ahead and divide here. So we can write this out as what we know it to be, x times x times x times x times x, divided by x times x. Now we know with fractions, when we have something on top of itself, they just cancel out. So when we cancel out, we are left with x to the power of 3. Now if you're clever, you might see a pattern here. All that we did was we took the 5 and we subtracted the 2. So we had x to the third. Let's try that one more time. So here we have 21, x times x times x times x times x, with 3 w's, over 9 times x, plus w 10 times. 2, 3, 4, 5, 6, 7, 8, 9, 10. Phew. Now we're going to cancel things that are on both the top and bottoms. These x's are going to cancel. These x's will cancel. We'll have this w and this w, this w and this w, this w and this w. Okay? So we can simplify our variables, and we can say we have x to the third on the top, and w to the 1, 2, 3, 4, 5, 6, 7 on the bottom. As far as the numbers go, we just treat this like any old fraction, and we say, what's our greatest common number that goes into each of them? In this case, it's 3. Now, 3 goes into 21 7 times, and 3 goes into 9 3 times. So this is our final answer. Okay, but as you guys saw, that was a little bit time-consuming writing out 10 different w's. So for this next one, let's go ahead and use our subtraction trick. Okay, so for this one, we're going to take our x's and subtract. We have 3 minus 4, which gives us negative 1. Now that one's a little bit tricky. When that happens, we are just going to put the x to the 1 on the bottom, okay, because we actually have more x's in the bottom. Same thing with the w's. If we do the w's, we have 9 minus 20, which gives us negative 11. So we're going to put 11 w's on the bottom since we got a negative number. Now the last thing is simplifying this fraction. The number that goes into 2 and 8 is 2. 2 goes into 2 one time, 2 goes into 8 4 times. So there is our answer. Okay, so go ahead and pause the video and write down rule number 2. If we are dividing exponents, we just subtract those exponents. Make sure this only happens if the bases are the same. So if I have an x to the 4th over x to the squared. If I had something like this, x squared over w to the 4th, I cannot combine those exponents because they are not same base. All right, this one's getting a little bit more tricky. We have x squared to the power of 3. Now we know to the power of 3 just means multiply times itself 3 times. So this is like writing x squared times x squared times x squared, which is the same as x times x times x times x times x times x. And we see we have 1, 2, 3, 4, 5, 6 x's, which gives us x to the 6th. Now again, being clever, we see that all we did there was we multiplied the exponents. All right, so x squared to the 3rd is just x to the 6th when we multiply. W to the 3rd is w to the 9th. And now we've got a tricky one. So let's do these one step at a time. Here we have x to the 4th to the 7th. 4 times 7 is 28. W squared to the 10th gives us w to the 20th. Y cubed to the 9th gives us y to the 27th. And that 6 just hangs out right in the front. All right, so go ahead, pause the video, and write down our next rule. All right, moving on. This is one that we've sort of seen a little bit of. If I have a negative exponent, for example, a to the negative 1 or x to the negative 1, all that means is we flip it, okay? So we're going to put it on the other side of our fraction. So this becomes 1 over x to the positive. Okay? In this situation, if I have a negative exponent on the bottom, this guy just flips to the top, and I get n to the 3rd on top. I could write over 1 if I wanted to, but I don't need to, so it's just n to the 3rd. So go ahead and pause the video and write this one down. All right, so here we go. We see a couple more examples. So let's simplify this guy. We see that w has a negative exponent, which we're not going to leave in our answer, so we're going to flip him to the other side. 2 doesn't have a negative exponent, so he gets to stay there. So I'm going to write negative 2 times w to the positive 3, now that it has switched sides. Now they can get pretty tricky once you have a lot of things going on, so let's do this one step at a time. We see that x has a negative exponent, so he's going to have to flip to the other side. So we're going to have x squared on the bottom. We see that z has a negative exponent, so we're going to flip him to the top. W has a positive exponent, so we're just going to leave him alone. He's just going to hang out up here. Okay, and then for our last step, we just treat this like a regular fraction, and we see that 3 goes into both of these numbers. So 3 goes into 3 one time, 3 goes into 12 4 times. Okay, now just so you know, we can clean this up a little bit. This 1 on top is not necessary, so I can skip it. And z to the 1st power is the same as just z, so I can write it like this. And on the bottom, we have 4x squared. So either of these is a correct answer. Okay, write this somewhere huge in your notes. Never leave negative exponents in your answers. We never, ever leave a negative exponent. If you have a negative exponent, you are not done simplifying. All right, so let's go ahead and practice a few. This is an interesting application, so let's just write out what this would be. xy to the fourth is just xy times xy times xy times xy. And here we see we have 1, 2, 3, 4 y's and 1, 2, 3, 4 x's. So when we have something raised to the power of 4, we just raise everything to the power of 4. So x to the fourth, y to the fourth. Okay, so add this to your notes. Whenever you have a power to a power, we just put everything in the parentheses to the power. Okay, there is one trick though. Before we get to that trick, let's practice a few problems. So here we have this one. We're going to do it one step at a time. 6 to the power of 3 is 6 times 6 times 6. And we have 6 times 6 is 36. And 36 times 6 is, let me pull out my calculator, 36 times 6 is 216. So the first thing we have is 216. Now we have a squared to the power of 3, which we just multiply. So this is going to be a to the 6th. Now we have b to the 3rd. This technically has an invisible exponent of 1, so 1 times 3 gives me b to the 3rd. And then we have c to the 4th to the 3rd, and 4 times 3 gives us 12. Okay, warning, this rule does not work if you have a sum or difference inside of the parentheses. So for example, you guys have seen this one before, x plus 2 squared. We cannot just square the x and square the 2. That doesn't work because squaring something means to multiply it by itself. And when I do this, I FOIL and I get x squared plus 2x plus 2x plus 4, which gives us an x squared plus 4x plus 4. If we had just done the squared for each of these, we would have completely missed this middle term. So only do that, all these things up here, if we have multiplication or division inside of the parentheses. If you have any sort of addition or subtraction in the parentheses, stop, write it out, and actually do that multiplication by itself. Okay, this is our last rule for the day. 2 to the 0. Take a second and guess what you think this is going to be. Okay, most of you probably guessed that 2 to the 0 equals 0. That's not right. Some of you may have guessed 2 to the 0 equals 2. That is also not right. 2 to the 0 actually equals 1. Now, a lot of you may be wondering, how the heck did you get that? So let me just prove it to you. In this unit, we are going to be talking about equations that look like this one, 2 to the power of x. So let's go ahead and fill in a table for 2 to the power of x, and we're going to start at the bottom of our table. Okay? So 2 to the 3rd, we know equals 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So we're going to plug that guy in right there. We'll work our way up our table, 2 to the 2. Hopefully you guys know this is equal to 4. And similarly, 2 to the 1 is just 2. Now let's see if we can figure out a pattern here. To get from this step to this step, and this step to this step, all we're doing is we're multiplying by 2. So it makes sense, if we want to go backwards, you just divide by 2. So let's go ahead and go backwards one more time. If we divide 2 by 2, we get a 1. So this rule tells us that 2 to the 0 equals 1. And similarly, with any number anywhere, 2 to the 0, 100 to the 0, 50 to the 0, anything to the 0, anything to the power of 0 equals 1. That will always be true unless you try and do 0 to the power of 0, which you just can't do. That's the only exception to this rule. Any negative number, any positive number, fractions, decimals, all of them raised to the power of 0 equal 1. Okay? Now, while we have this table up, let's just keep filling it in. 1 divided by 2 is 1/2. 1/2 divided by 2 is 1/4. Now, if you guys are clever, you will see there's a connection. Here we have a 2. Here we have a 2. Here we have a 4. Here we have a 4. So, if you have 2 to the power of -1, it's the same thing as 1 over 2 to that positive power. Okay, so that's a little bit confusing. We'll talk more about that in class. The big thing here is to know that anything to the power of 0 equals 1. So go ahead and add that to your notes. Anything to the power of 0 equals 1. 10 to the power of 0 equals 1. Star to the power of 0 equals 1. Infinity to the power of 0 equals 1. Anything to the power of 0 equals 1. All right, so here's some really complicated examples. Go ahead and give these a shot, doing one section at a time. We will be practicing problems like this in class. Good luck.